Okay, so the last class we understood that like hey, we need to capture four-way handshake. That's the bottom line. Maybe let's try to understand what this four-way handshake contains. What can we do? So if you see here, you have four messages basically. First message from access point to client, sending something called a nouns. You can think a nouns is like a random number, but maybe you can use Wireshark to see. Let's use Wireshark. Let's search PCA PNG, I think. So let's say EA pool. So this is already I captured the four-way handshake. I think I got only three messages, but I can find one more handshake. So if you look at the first message, let's say this message, look at it. I'll extend this. You will find some data here. You see all data is right there. Yeah, you see some data is there. So if you see the first packet data, something like this one, authentication. So there has to be nouns. So okay, this is the nouns. It's a random number they generated. So that's the first packet. So that's what the guide also says. First access point will send a some number, random number to the client. And that random number is this number. That's the first message. The second point, second pack has client will send a access point, another nouns, another random number, plus some proof of password. We'll see that what that means. But now let's look at second message. You can see, just compare it. You see, just observe this is changing. Just see. You could observe that. Sorry. So for example, first one starts with B34415. Second one starts at 90AB. So it's a different nouns basically. And also if you observe some other additional data, let's see. Anything additional data? Okay, this is a good one actually. It looks like this is an error packet, malformed packet. But anyway, so the idea is first this sends one number. Wi-Fi to client, you get one number. Then client to Wi-Fi, you get another number, some password proof. Then again, AP to client, there is something called GTK. So these are basically mathematical things only. Maybe I can say we basically calculate. I want to. I want to see the calculations with a simple example. With a simple example, and to end. Sorry, example. For decoding password. Wi-Fi password. Yeah, so basically, the data transfer from A to B, B to A, again A to B, and finally you have B to A. So this you can call connection established, like it's a handshake. So if you capture all of this data, you will get these codes like these only. For example, you know the nouns, first nouns, you know, this is the nouns. You know the second nouns. There is something GTK key also somewhere might be there. So you capture all of these things. So let me, it's giving text only. Ah, You see something like, assume that Wi-Fi password is something, 1, 2, whatever, doesn't matter for us. Uh, First step, AP access point will send client one number. Let's think that number is 7. Example. Let's just say it. So the number is 7 is passed to the client. Client also will send another number. Let's say number is 3. Example. Then it uses some equation actually. It's a mathematical equation. Something like this one. You can see they calculated PTK with based on these values. You have a client MAC address that you already know. Access point MAC address, you probably know. S nouns, you know. A nouns, you know. Only thing you don't know, what is this? The rest you already know all these data. This you don't know. We'll come to this later. Yeah, so we'll see that how PMK is derived, but you can see all the numbers are added. Finally, you get something called 355 number, something. Now, what they do is, then they did something like with that PTK, they multiplied with the 2, they call it MIC, example. Now, client will send that MIC back to AP. So that's the third process. Yeah, you can see all the process. A nouns, you know, S nouns, you know, MAC, you know, client, you know, finally you get 355. And then finally, I see access point, encrypted GTK 1, 2, 3, 4, client. I will just say AP max from 1K or encrypted GTK under PTK, simply like 99. These are GTK plus PTK sends encrypted to the client. Okay, okay, let's see. And okay. So here there are few definitions you should know. PTK, PMK, all these numbers. Let's say PTK, MIC, GTK. So these are basically keys actually. So whenever you send password on your Wi-Fi enter, the password does not directly go to the router actually. It is somehow decoded into these kind of logics, and that logic will go to the router. So directly password will go, if anybody can snip, they can easily see it. So that's why passwords don't go directly. They use these sort of equations only. For example, PTK they call pairwise transcendent key. It's mostly, it encrypts the traffic between two parties, which is client and thing. So it follows some equation with these details. Like example, PMK, some number is there. All these numbers, you know, it does basic addition. Then there is another code, something called message integrity code. What this is, like in a way, it's like a secret code language. For example, let's say I say hello as a code word for you and me. When I say hello, you say hi. Example. So whenever I say hello, you will understand, okay, hello means hi. So that's a code word between you and me. Now, if I go talk to somebody else, there is a different code word. So that's what exactly Wi-Fi also does. So the access point sends some code to the client. Client will send using that code. It sends the password. You do some calculation. You come back here. In that way, they both can understand that, okay, these are authentic guys mostly. So that's the process actually. Again, the actual computation is a little difficult, but here they're saying very simple, like 7, 2, 3 numbers. But actual values are mostly like these only, big values like these. They will not do basic addition. They will do bits addition, like 1 0 1 0 1 0 1 0 like that. But here they give like a formal simple thing. Again, you don't need to do all these things to understand it, but I can tell you that all the data is somewhere here only. You can capture it. I mean, you can see it, like maybe message 3, let's see. So the GTK key, everything will be there here. All you need few things. One is you need GTK, you need sender, S nouns, for example, here given. A nouns, S nouns, you will capture it. MAC address, of course, you know both. It's easy. This PMK, you will get it like somewhere here. And based on that, you will get the something called GTK. Once you get the GTK, you will get something like a hash. Some hash you get like, example, some hash like 4, 6, like something like example, some hash. This is actually the password. It's like a coded language only. For example, let's say if my password is ABC, I cannot directly send my password. What I do, I change it. Maybe I'll say something like, in terms of A, I'll put Z. In terms of B, I put Y. In terms of C, I put X. How does it work? I can say ABC minus 26, 25, 26, whatever. So this is my coded language. So when I give ABC, I will not directly send ABC to the via bytes, I mean signals, because anybody can capture. I'll add small logic code. The logic code here I give is like minus 26 or plus 26. What's a plus? So if you add A equals 1, 1 plus 26 equals 7. So 27. 27 means Z. I mean 26 is Z, but it come 1 5. Something like that. Numbers you can change. In terms of A, I'll get Z. In terms of B, I'll get Y. In terms of C, I'll get X. Now, in a way, nobody can decode this unless they know this logic. So that logic, only you have to figure it out. But that logic is easy only. But what you can figure it out is, I mean, mostly if you capture the four-way handshake, all the information is there. I can tell you that. The information is there in the fields. You will just have to find those keys and do a basic bits addition or subtraction. That you can do it very easy. Think like this: if you capture the four-way handshake, you already cracked the path. I mean, you already know the hash. That's for sure. It's just a matter of finding it actually. Where to find, we'll have to see. So these are actually bad packets, so I cannot see all the information. But first, let's try to capture the four-way handshake. One time, if you capture four-way handshake, you will find all the information here only. All the keys, MAC addresses, everything will be here only. And using these key, see MIC. It's missing right now because the frame is bad. But if the frame is good, the MIC might be there. The MIC might be there. So all the data is there. Based on this data, you will get something called hash. That hash is actually password like. That is the Wi-Fi password. You have to decode the hash actually. So we'll cover hash decoding later classes, hash cracking. I think we have our platform. We can try hash cracking, something like this. For example, if you give a password ABC, so there are a bunch of hashing algorithms. These are different hashing algorithms. Let's give 1, 2, 3, 4. Generated. So this is the hash. 1, 2, 3. You will get 1, 2, 3, 4. Every time you give 1, 2, 3, 4, you will get same hash only. Hash will not change. But if you make a small difference, like 1, 2, 3, 5, the hash will completely change. Sorry? You can try, but right now again, this is just lab only. You cannot crack it in this lab, but you can. Offline, you do that. Offline, what you do is something like this. For example, let's say the actual password is 1, 2, 3, 4, but you don't know. Let's say you only know the hash. Let's say you only know the hash, something like this hash. You don't know what that hash is like. What do? You try something like dictionary attack. Dictionary attack means you already have a bunch of computed hashes, their corresponding passwords. They're mapping. Now, what you can do, you can try each hash matching this hash or not. You can even try it. Actually, there are some online tools available, but let's say crack station. So let's say this is one, 3 character. Here if you enter that one hash, enter up. Let's see if I enter that hash. I'll add this hash, copy. I will paste it. I'm not a robot. Crack hash. You can see it found. I just entered the hash. I got the result. Let's try it. Let's give something like test 1, 2, 3. Generate hash. Copy. Paste. I'm not a robot. Crack. And see, we get the password. Again, it depends on how strong is the password. If the password is too strong, I'll write some random thing. It's like too strong password basically. I generate the hash. It's very hard to find this exact password because you can see not found because the password is like too strong. Like nobody can usually decode this password. But if you try common password is, let's say, I don't know. You tell me some common passwords. Let's say, I so let's try one by one. Okay, I love you is also not found. It looks like okay, it's loading. Ah, ah. You can tell some common. I mean, not common, but uh, sorry, 25 8025. Okay, it's a password. It's a number. Okay. Hmm. It's there. So yeah, it depends on the how big is the number, like how big is the password or how strong is the password. Typically, people, of course, new people usually give like very simple passwords, common passwords, number passwords. They can easily be crackable via this crack station. Crack station is nothing but it's a bunch of. You can also do it by yourself. You don't need to use this only, but they provide you something like a database of all hashes and the corresponding passwords. They have, I think, 1 billion. You can see 1.5 billion hashes are there, corresponding passwords are there. It's like 19 GB database. Typically, what in cybersecurity, what people do is like attackers, they download these files separately. They will only do it like check on the all the hashes. So we'll see hash cracking maybe in coming classes, but right now you get some idea what actually happening. Like, so that's one. Yeah, you can use different algorithms. For example, this is common algorithm. This is old. This is very easily decrypt. This one. Uh, this is a little advanced. These are very hard to crack. Uh, Very hard to crack these things. But still, if you have bad password, then you will crack it. Yeah, different algorithms are there. This is one algorithm. This is another algorithm. You can see you can also upload bunch of passwords. We call it a brute force. Brute force means you try every possible password, like ABC, ABCD, ABC, ABC, exactly similar. Something like test. Um, we'll see hash cracking. We'll see hash cracking in separate thing, but both combined in a way. In order to crack any password, You need to know hash cracking, but that's a separate thing altogether. But coming to our Wi-Fi related, the main thing in Wi-Fi is first get the handshake, and handshake contains all the information. And you just write a small program, which you can find it on ChatGPT, wherever, to decode the hash. Once you get the hash, you can now use some other tools to decode the hash into password. So that's our example. If the password is too strong, then it's very hard to crack. If the password is somewhat medium to low, then you can crack it. So it depends on how strong is the password. The password could be strong, or password could be easy. So yeah, so we have some simulations here where you can try, like when you will get some idea only. It's not fully like real time because it's just a simulation, but you can try some ashes and see what happens. You can upload some board list or something here. So this is how people usually do that, like mostly. Yeah, I think probably that's Wi-Fi is that much only you need to know. But you can do a lot more stuff once you understand the basic packet capture. Four-way capture you do. You can send de-authentication request. That's also easy actually. So de-authentication means like one mobile phone is connected to the Wi-Fi. You know the mobile phone MAC address or something. You know about that. You can send them de-authentication request, which means the mobile phone will be disconnected from Wi-Fi. Now, typically what they do is they'll try to connect again. When they connect again, you will capture the four-way handshake. So that's how you can do de-authentication request sending easy only. But you need to know their MAC address, exactly. Yeah, they have a mobile. Yeah, you have a mobile phone connected to Wi-Fi. You know the mobile phone MAC address and everything. You will send a frame to the mobile phone. But again, key point, you only manage your network. You will send some frame to your mobile. The mobile will automatically disconnect the Wi-Fi. Obviously, usually nowadays all mobiles are auto connect. They try to auto connect. When they try to auto connect, you capture the four-way handshake. So this is how people, mostly hackers, do outside, like coffee shops and everywhere. Uh, that is one. Maybe another attack you can think like fake access point. For example, I carry a small, let's say, wireless device, example Wi-Fi, small chip. I'll create multiple fake, uh, fake Wi-Fi's, hotspots. Example, I sit at a coffee shop. I'll say that, hey, coffee free Wi-Fi. Example. I'll create some example like these. Let's say, example, free Wi-Fi. Maybe I'll add that coffee shop name or something. Something like that. Example, Degen Den guest. So the customers who come to the coffee shop, they might probably click. I mean, not everyone, but at least some people might be interested to click. When they click, obviously, you know their address and everything. You can, in a way, steal some of the information from them. So that's one attack. But that happens with a physical device. You have to have the physical Wi-Fi signal device that emits the signal everywhere. So whoever is connected, you can steal their data. That's one. That's one attack, fake access point. Of course, another attack you already know, de-authentication, but it's not an attack. It's just to disconnect from the internet, Wi-Fi. That's it. So disconnects it. That's one attack. Maybe another attack would be man in the middle attack. but that's also very much same, which means they act the router itself. Now let's say you are connected to Wi-Fi via router, and somebody hacked the router, so they know everything you are sending to the router sending it to you. So they are in the middleman, right? So they can capture some information, they can steal some, or they can fake some. So it depends on the attack. Like this usually happens actually. Wi-Fi attacks are common, but they are very geo-specific. You cannot do Wi-Fi attack sitting somewhere else. You can only do Wi-Fi attacks nearby. You can only be nearby only. So yeah, coffee shops, public Wi-Fi's, public places where a lot of people gather, you can do these kind of attacks mostly. Like at conferences, like in a conference, a lot of people come, right? So hundreds of people or thousands of people. Then you can create some fake access points. At least 1,000 people, at least 10 people might get connected. Not everyone. So in a way, you can steal some of the information from them, mostly the financial information or personal information, depends on the interest in this. Maybe Wi-Fi attacks are this only. One is password cracking, fake access points, man in the middle attack. But man in the middle attack also you can do, but by hacking the router directly. You can hack the router the way you hack the network router, not necessarily Wi-Fi, but you hack the router via networking concepts only, not like Wi-Fi concepts as well. But you know what router is sending, receiving. You can control it in a way. So in a way, you can fake it also. You can steal some information over there. And these are very hard to track actually. Because nobody's know what's happening in Wi-Fi. For example, let's say if I go type google.com, I'll get the google.com page, very common. But imagine instead of google.com, I'll get some dummy, I don't know, some vulgar image or something. Then I can understand, okay, something happened with the Wi-Fi or something happened with the internet. Yeah, so that's the attack part. I think defense also we can see, but defense is most like one is strong password you maintain and use the encryption like WVPA3. That's a strong encryption. So even though you use weak password, the encryption is strong, so it's very hard to do it. That's one. Strong password is another defense. Maybe third difference is allocate only if you want known MAC address, like a firewall. Allow only known MAC address. Every time when a user wants to connect to the Wi-Fi, you take their MAC address, you register them in the Wi-Fi, so they only can enter. These three are the strongest. So obviously the first one I recommend or anybody recommend is strong password. The Wi-Fi password should be strong. Encryption is the next priority. This you usually do last unless you know it. So that's the defense only you can say mostly. Is there any other defense? Mostly that much only. Mostly Wi-Fi's are that only. There is no, maybe you can add a defense like if you know, you can add some admin mode. You can track and understand the behavior and control the behavior, control the internet or control the access. But this is more like a programming one. It's not a cyber security. Like you have admin mode. So for example, you can log into the admin mode of the Wi-Fi. You can see which device is consuming more content or more traffic. So you will understand the behavior of the device. You might either block it or limit it, depends on the interest. But this is more like a admin network engineer mode, not a cyber security mode. There is not much security here, but analysis you can do. Yeah, I think that's pretty much it. The first thing I recommend is try to capture the 4-way handshake. Then you will try to, I'm pretty sure you will find the hash. And after hash cracking, you will understand how to crack hash also. So when you put together, you have a bigger understanding of what to do later. Slowly, we can go for encryptions also. How encryption works, how data is encrypted, how you can decrypt also. Typically, if there is a way to encrypt, there is a way to decrypt also. It's not like that. But how strongly you encrypt matters. If you strongly you encrypt, it's hard to decrypt. If you weakly encrypt, it's easy to decrypt. Example, right now it's very easy to in a way decrypt. Anybody can, by looking at Z, Y, C, they might they might easily crack. But if I add bunch of like weights, bunch of numbers, bunch of digits, example, and finally I get something like this, then it's very hard to crack because the encryption I use is like super hard. Like I can, so it's very hard to figure this one out. Yeah, I think that much only. I think you should know for Wi-Fi. You only any questions? Maybe I will make a note. Actually, we captured one frame. Wi-Fi password is it's there. Maybe it's not on this computer. There is something we captured actually here only. But, but I can only see one, two, three only. Anyway, we'll try to capture it today. Actually, I have pen drive. If you can try it, you can try it actually if you have. I was trying on my computer, but it's not working. So we'll see. I'll try to capture it maybe today. If I make it work. We'll see maybe upcoming things, how I can see the information of all the keys and using those keys and decode the hash. Using the hash function, I mean hash decoding, I can decode the password there. Yes, any questions, anything before we close? Sorry.